Hello everyone. In this video we are going to see one more example of finding minimal finite automata. I have already explained the algorithm and an example to find the minimal automata in the previous video. See the DFA in front of you. This is the DFA and sigma is 0 or 1, two symbols. Start with the first phase. In phase 1, we will pick all those pairs of the states where one of the state is an accepting state and the another state is non-accepting state. For example, if I take 2 1 2 1 in this pair, we have both 2 and 1 which are non-accepting state. So in this phase this pair is not marked. Similarly 3 1, both of these are not accepting, so we will not mark it. 3 2, both of these are not accepting, we will not mark it. Similarly 4 1, 4 1 is both 4 and 1 are non-accepting, so not marked. 4 2 not marked. 4 3 not 4 2 is not marked because of the same reason, both 4 and 2 are non-accepting states. Similarly 4 3 not marked because both of these are non-accepting states. 5 1 5 1 again, the same reason, both 5 and 1 are not non-accepting states. 5 2 not marked because both of these are non-accepting state, and so on with this for the same reason. 5 3 5 4 are not all are non-accept, both of these are non-accepting, so they are not marked in this phase. Start with 6 1. In 6 1, 6 is an accepting state and 1 is not an accepting state, so I will mark 6 1 here in phase 1. So I put number 1. 6 2, again 6 2 is marked because 6 is an accepting and 2 is not accepting. Similarly 6 3 is marked, 6 4 is marked, 6 5 is marked, 7 6 is marked because 7 is non-accepting and 6 is an accepting state. So here we have completed phase 1 of the algorithm. In phase 2, we'll restart in the second phase. Start from cell 2 1 and follow the algorithm. Find out the transition of state 2 on reading symbol 0. Similarly, transition of state 1 on reading symbol 0. Delta 2 comma 0, that is 2 on reading 0, is going to state 5. See the diagram. Similarly, 1 on reading 0 is going to state 2. 5 2. So this check if 5 2 is marked yet. No, 5 2 is not yet marked. So we will not mark 2 1. But since we have another symbol 1, so I'll check for symbol 1 also. 2 on reading 1 is going to state 4. Similarly, 1 on reading 1 is going to state 3. Check this pair 4 3. In the table 4 3 is not yet marked, so I will not mark 2 1 right now. Again check for the cell 3 2. Repeat the process. 3 1 for 3 1. 3 1. 3 on reading 0. 1 on reading 0. 3 on reading 0 is going to state 6. 1 on reading 0 is going to state 2. So we get pair 6 2. Check if 6 2 is marked. Yes, 6 2 is already marked. So I will mark state 3 1 here. And since we are in phase 2, I'll write 2 here. Similarly, check for the pair 3 2. 3 2. 3 on reading 0 is going to state 6. 2 on reading 0 is going to state 5. Check if 6 5 is marked. Yes, 6 5 is marked. So I'll mark this 3 2 also. Now we will go and we'll check for the pair 4 2, 4 3, 4 4, 4 4 5 and So check for 4 1. 4 on reading 0 and 1 on reading 0. 4 on reading 0 is going to state 5. 1 on reading 0 is going to state 2. 5 2 is not yet marked, so I'll not mark 4 1 for symbol 0. Check for symbol 1. 4 on reading 1 is going to state 4. 1 on reading 1 is going to state 3. So 4 5 2 and 4 3 both the pairs 5 2 and 4 3 are not yet marked. So I will not mark 4 1 right now. Then we'll check for another pair 4 2. 4 2. 4 on reading 0. 2 on reading 0. 4 on reading 0 is going to state 5. 2 on reading 0 is also going to state 5. Similarly, 4 on reading 1. 4 on reading 1 is going to state 4 delta. 2 on reading 1. 2 on reading 1 is going to state 4. Now see what we get for this 4 2 cell. The output is 5 5 for symbol 0 and for symbol 1 the output is 4 4. Remember that this 5 5 and 4 4 is not going to be there in the table. It is not found in the table. So therefore 4 2 cell is never going to be marked. It will not be marked ever. Not in this iteration, not in the further iterations. Now we will move to the next cell, that is 4 3. Check the same thing for the cell 4 3. So 4 on reading 0 and 3 on reading 0. 4 on reading 0 is going to state 5. 3 on reading 0 is going to state 6. And cell 5 6. 5 6, that is this one, is already marked. So I will mark the place 4 3. Cell 4 3 is marked. Now again repeat the process for the next row, that is 5 1 5 2 and so on. 5 1. 5 on reading 0 and 1 on reading 0. 5 on reading 0 is going to state 6 and 1 on reading 0 is going to state 2. 6 2, check the cell 6 2 is already marked, so therefore 5 1 is marked. Now repeat the process. 5 2. 5 comma 0, that is 5 on reading 0 is going to state 6 and state 2 on reading 0. State 2 on reading 0 is going to state 5. Since 6 5 is already marked, so therefore 5 2 is marked here. Repeat the process for 5 3. 5 3. Sorry, this is 5 3. 5 on reading 0. 5 on reading 0 is going to state 6. 3 on reading 0. 3 on reading 0 is going to state 6. 5 on reading 1 is going to state 7 and 3 on reading 1 is going to state 7. Now see what we are getting. For symbol 0, the pair 5 3 is giving the transition with the output 6 6, and for the symbol 1 it is giving the output 7 7, which we know that 6 6 and 7 7 will never be found in the table. There is no such cell with the number 6 6 7 7. So therefore 5 3 is not marked ever, not in this phase, not in the next phase or any other phase in the algorithm. So now we'll check for cell 5. So just note down somewhere that is 5 3 is never going to be marked. This I will write here, that 5 3 will never be marked. And similarly we had, I think, 4 2, which was never be, which was giving the output like AA type. For example, delta 4 on reading 0 was giving us value 5, delta 2 on reading 0 was giving 5, delta 4 on reading 1 was giving us 4, delta 2 on reading 1 was giving us 4. So 5 5 4 4. In the same category, that is 4 2 is never going to be marked, not in this iteration, not in the future any of the iterations. So now we'll move to the next cell, that is 5 3. Repeat the process, 5 on reading 0 and 3 on reading 0. 5 3 we have already checked, sorry. 5 4. 5 on reading 0 is going to state 6. 4 on reading 0. 4 on reading 0 is going to state 5. Check 6 5 is marked. Yes, 6 5 is marked. We can see here. This is the place 6 5 is marked. So 5 4 is also marked, and we will put this value here. Now repeat the process for 7 1, 7 2, 7 3, 7 4 and 7 5. 7 1. 7 on reading 0 and 1 on reading 0. 7 on reading 0 is going to state 6, and 1 on reading 0 is going to state 2, that is 6 2, and since 6 2 is marked, 7 1 is marked. Similarly 7 2. 7 on reading 0 is going to state 6, 2 on reading 0 is going to state 5. 6 5 is marked, so this is also marked. Now repeat the process for 7 3. 7 3. 7 on reading 0 is going to state 6, and 3 on reading 0 is going to state 6. Now take another symbol, that is 1. 7 on reading 1 is going to state 7. 3 on reading 1 is also going to state 7. Now see, again we have this category of the choice where 6 6 7 7 is there, and 6 6 7 7 is never going to be available in the table. We can clearly see the table. We do not have cells with 6 6 7 7 values, so therefore this 7 3 is not going to be marked ever. I'll write it here, 7 3 is never going to be marked. Now move to the next cell, that is 7 4. 7 4. 7 on reading 0. 7 on reading 0 is going to state 6. 4 on reading 0. 4 on reading 0 is going to state 5. 6 5 is already marked, so 7 4 is marked. Now check for 7 5. Repeat the process for 7 5. 7 on reading 0 is going to state 6. 5 on reading 0. 5 on reading 0, see the diagram, is also going to state 6. Now check for symbol 1. 7 on reading 1 is going to state 7. 5 on reading 1. 5 on reading 1 is also going to state 7. So again we are getting this kind of output, that is 6677, where 66 and 77 is not available in the table. So therefore 75 is never going to be marked. So I'll write this as blocked. It will never be marked. Now we are in the phase 3 of the algorithm. We'll again see 2, 1. 2 on reading 1 and 1 on reading 1. Check if 2 on reading 1 is going to state 4 and 1 on reading 1 is going to state 3. Check if 4, 3 is marked. Yes, 4, 3 is already marked. So I'll mark 2, 1. Check, this is 4, 3. 4, 3 is already marked. So I'll mark 2, 1. And since we are in phase 3, I will write number 3 here. Now we'll check for the cell, unmarked cell 4, 1. 4 on reading 1 and 1 on reading 1. 1 on reading 1 is going to state 3 and 4 on reading 1 is going to state 4. See the transition, 4 on reading 1 is going to state 4. So 4, 3, 4, 3 is already marked. So therefore I'll mark this cell 4, 1. Now we know that 4, 2. 4, 2 was already blocked here. It is not going to be marked ever. So I'll just put this. It is not going to be, it remains unmarked. 5, 3. 5, 3 is also blocked. We know the reason why. 5, 3, 4, 2, 7, 3, 7, 5. They all are unmarked forever. We know the reason because on the transition of with 0 and 1 they are giving the output like A, comma A, that is, and we do not have such values in the table, so they are not going to be marked. They remains unmarked in the whole algorithm, the whole solution. So now this 5, 3 is unmarked. 7, 3 is again unmarked. 7, 5 is also unmarked. Now we will stop the algorithm and we will make the diagram for this table. Now perform the union operation. Which states are going to be merged together? See this 2 on 2, there is vertically there is one cell which is unmarked. What is the number? This is 4. So 4 and 2 are going to be merged into one cell. I'll call it P1. Say P1 is some state where we will combine, that is perform the union of 4 with 2. The state 4 and 2 are merged into 1 and we are calling it say P1. Now come to the next unmarked cells. This place is unmarked. This place is also unmarked and it is aligned on what state? 3. So we will perform the union operation of 5, 7 and 3. And suppose I'll call this name it as P2. So there we have 5 union 3 union 7. Now we are done. See this unmarked cell 7, 5, 7, 5, 7 and 5 are already merged into 1. So now we will make the diagram. Start with the first initial state is 1. 1 on reading 0 is going to state 2. 1 on reading 0 is going to state 2. Where is 2 right now? It is in P1. So I will put P1 here. 1 on reading 1 is going to state 1 on reading 1 is going to state 3. Where is 3 right now? It is with P2. So I will write P2 here. So now for transition of P1, how many states are merged in P1? 4 and 2. See the transition of 4 and 2 in the original table. 2 on reading 1 is going to state 4. Where it is? 4 is in P1. Similarly, 4 on reading 1 is also going on 4. 4 is in state P1. So I will have this loop here. For P2, for P1 reading 0. P1 on reading 0, we will see the transition of state 2 and 4 on reading 0. State 2 on reading 0 is going to state 5. 4 on reading 0 is also going to state 5. Where is 5 right now? It is with P2. So I will make this diagram. So now for the transition of P2, we will see the transitions of 5, 3 and 7 in the original table. So 5 on reading 0 is going to the state 6. 3 on reading 0 is also going to the state 6. 7 on reading 0 is also going to the state 6. So all the 3 of these on reading 0 is going to the state 6, and 6 is the accepting state. Now P2 on reading 1. See the transition of 5, 3 and 7 on reading 1. 5 on reading 1 is going to state 7. Where is 7? 7 is in state P2 only. 7 on reading 1 is going to state 7, which is with P2. Similarly, 3 on reading 1 is going to state 7, which is also with the P2. So therefore, P2 on reading 1 stays on P2. So the transition of P1 is completed. The transition of P2 is completed. The one transition of 1 is completed. The state 1 is completed. Now for 6. 6 on reading 0 is going to state 4. Where is 4? 4 is with P1. 6 on reading 1 is going to state 5. Where is 5? 5 is in P2. So this is the final diagram for the given automata. We can see that some of the states are merged into one state, and now this is the minimal finite automata. Hope the concept is clear to all of you. Thank you so much.